And this is part 2 of the Geometry Test 1 review. I've been having such trouble with uploading that I'm doing it in parts for today. So here we pick up on problem 10, and it says, classify each cone or cylinder with the most specific designation possible and as a polyhedron if possible. So for part A, we can see we have a triangle base with 3 sides, so that's a triangle pyramid. And with 4 sides, there are the 3 sides in the base. It's a tetrahedron. For part B, we have a triangle front and back, which makes it a prism. So there's 3 sides, and front and back makes 5 sides altogether. So that's a pentahedron. And for part C, we have a circular cone. Now for 11, this is from section 1.8. We say name each type of figure. An accurate figure made with tools such as a protractor, ruler, or template. That's the most accurate thing we can draw, called a drawing. Now what we do in class is a figure made with a compass and a straight edge, and that's called construction. But a freehand figure made with only a pencil or a pen is the least accurate, and that's just called a sketch. Now for 12, it asks us to use symbolic notation to write each statement. So we have a line J, a line K, a line L running through both of them with point C at the intersection of J and L and D, and then the whole plane M. So if we ask to do point D as an element of line L, then we just write D, the element symbol, and then L. And if we're to do line K as a proper subset of plane M, we do K with the subset symbol with no equal under it, and then M. And lines J and L intersect at point C as J intersect L equals C. Now the next problem, 13, is sometimes, always, or never. So 2 non-intersecting lines are parallel. This has to be sometimes because they are parallel if they're in the same plane. But if they're in different planes, skew lines, then they're not. So this is a sometimes. So 3 and part B, 3 collinear points determine exactly one plane. That's not true. We need 3 non-collinear points, 2 points on a line and 1 point off to make a plane. That's a postulate. So that's a never. And then we need, for 2 points are collinear, that's always true. So that would be an always. We can always make a line through 2 points. Then for problem 14, we have true or false. So a circle is a region, true or false? Well, a region includes the circle as well as the interior, so this would have to be false. But a curve is a continuous set of points, which just means that you draw without lifting up your pen or pencil, and so that is true. Then we'll look at C, all prisms are cylinders, which is true because they're cylinders with just a polygon base. And for D, all cones are pyramids, which is false because a cone could be circular and not be a pyramid. And then a square is a regular polygon. This is true because a regular polygon just means that the sides are the same and the angles are the same, which is certainly true for a square. Now to copy angle ABC using a compass and protractor, we look at the angle that's printed in the test and we put our point of our compass at B and make an arc from A up towards C. And then we go over to the thing that we're copying to and we have drawn a line already from E to D, and we put our compass point open to the same distance it was from B to A, from E to wherever it falls on that line, and make the same arc up towards where we think it will be, and then a little more as we did over on AC. So the arc from AC we copy over to D and then up. And then to get where it crosses, we take the point at A on the original and then draw an arc up to where it hits the top ray at C. And then we copy that distance, that opening, and put the point at D and make an arc. And then we draw from E to where the arcs meet. And that's how we copy our angle ABC. Now for 16, we want to find the two segments that make up the total segment, PR, which is given as 102. So PQ is given as 4 parentheses x minus 3, and QR is given as 6 parentheses 2x plus 3. Now if we multiply those out and set them to 102, we get 4x minus 12 plus 12x plus 18 equals 102. And adding the x's, we get 4x plus 12x is 16x, and negative 12 plus 18 is plus 6 equals 102. Subtracting 6 from both sides, we get 16x equals 96. Dividing 16 into both sides gives us x equals 6. But we're not done because we have to go and plug back into PQ and QR to find the lengths of the segments. So plugging in 6 for x, we have PQ is 4, 6 minus 3, or 4 times 3 is 12. And QR is 6 times parentheses 2 times 6 plus 3, or 6 times 15 is 90. And 12 plus 90 is 102, which is the original length. Now for 17, we want to find both coordinates of x if the coordinate of y is 11 and the distance between x and y is 48. So we have to set up an absolute value equation. xy, the distance, is equal to the absolute value of x minus y. Now we know that xy is 48 and that y is 11, so 48 is equal to the absolute value of x minus 11. And so with absolute values, we set up for the positive and negative of the outside number. So for 48 equals x minus 11, we add 11 to both sides and get x is equal to 59. For the minus 48 side, we add 11 to both sides and get x is equal to negative 37. For 18, we're now wanting to find the measure of three angles, measure 1, measure 2, and measure 3, which add up to a straight line, or 180. So we're told that measure 1 is 3x minus 1, measure 2 is 2 parentheses x plus 11, and measure 3 is equal to 2x minus 9. So 3x minus 1 plus 2x plus 22, multiplying through the parentheses, plus 2x minus 9 equals 180. And then the 3x plus 2x plus 2x is 7x. And the 22 minus 1 minus 9 is 22 minus 10, or 12. And then 180 minus 12 is 168. And dividing both sides by 7 gives us x equals 24. But now we have to plug back into the original angles just like we did for the line segments, making measure 1 3 times 24 minus 1, 3x minus 1, which is 72 minus 1, or 71. And measure 2 is 2 times 24 plus 11 in parentheses, or 2 times 35 is 70. And measure 3 is 2 times 24 minus 9, 2x minus 9, or 39. And those all add up to 180 as our check, which they have to. Now number 19 is to find the radius of a circle with a circumference of 48. So now the equation for circumference is c equals 2 pi r. Plugging in 48 for c, we have 48 equals 2 pi r. Dividing both sides by 2 pi, and simplifying 48 over 2, we have 24 over pi, but we need to use the pi on the calculator, not 3.14. So 24 divided by the pi in the calculator comes out to 7.63 to 2 decimal points. Now for 20, we want to find the number of sides of a polygon that has 65 diagonals using the equation D, the number of diagonals, equals n minus 3 over 2. So plugging in 65 for D and multiplying both sides by 2 to cancel the divide by 2, we get 130 equals n squared minus 3n. We subtract 130, so we have n squared minus 3n minus 130 equals 0. Then we need two numbers that multiply together to negative 130, but that are 3 apart, which we need negative 13 and plus 10, so it factors to n minus 13 and n plus 10, and changing signs to solve, we have n equals 13 as the number of sides, but n minus 10 we have to throw away. So that's the end of the review, Landon, and this will be coming in as part 2, which I'll send to you.